Go.
Poopy clouds.
Hello, Mr. Aaron, Mr. Brian, how are you today? Okay, so
Good.
we're going to learn some math today, probability. Okay,
Yeah,
so can
I
you...
know what all about probability.
Probability, what's probability? Probability, okay? Probability, what's probability? It describes how likely an event happens, right?
It's just a guess.
Okay, yeah, like it's going to rain. It probably goes to rain tomorrow. Probably, English word probably.
50%.
Possibly. Which one is more likely? Probably or possibly?
Possibly.
I don't know, in English. If you say it's going to be raining tomorrow, it's probably going to be raining, or it's possibly going to be raining tomorrow.
Probably.
Probably gives more probability, yeah? So it's more chance.
It's like something written.
Yeah.
Percent.
So probability is like it's a number, it's a fraction number between 0 to 1. Okay, you can say it's below 0, this, remember? 0 to 1, right? This means inclusive, right? This means exclusive, remember? Yeah? Parentheses, exclusive. Square bracket, inclusive. We can use the numbers, fraction number between 0 to 1 to denote this probability, or we can use the integer, or the number between 0 to 100, but we put a percentage, right? 100% is always going to happen, right? Yeah? Yeah, tomorrow, it's 100% it's going to rain. So we know, tomorrow it's definitely going to rain. Yeah?
How do you know?
No, I'm just guessing.
But how do you know if it's 100%? There might be so dumb.
Yeah, it's not. I'm just using this as an example. 100%, right? Yeah. So we are going to talk about probability today, right? Like for example, like I give you let's draw a 3 box, okay? I give you these 3 box, and I tell you that one of them has a coin in that. Okay.
Yeah.
So what's the probability of the first box has the coin?
33.
1 over 3, yeah, 33%, okay? Okay, so now if I tell you, okay, so this is called prior. Well, how do you pronounce this word? Prior probability.
I say it's pure.
Oh, okay.
Pure.
It means that before the new information is given, this is the probability. We know so far that the first box has the coin. The probability is 1 over 3. And how about if I tell you that, okay, if I open the second box, and then we found like there's no coin. So what's the probability of the first coin? First box has the coin.
Half. 50.
Half. Yeah, we're done. Because we already know that with the new information is given, we know this doesn't have a coin. So the coin must be in the first box or the third box. So this probability is 1 over 2. Okay, a half. Okay.
Yes.
This is called posterior probability. Okay. Probability. Okay. Probability. Yeah, makes sense? Yeah? Yeah? Okay, so now, let's say, okay. Let's say what? So, okay, so, you know the probability, you can multiply it together, okay? So, let's say you have 2 boxes, okay? You have 2 boxes, right? And each box has a coin, but the coin has 2 sides, right? Yeah? Yeah?
Mm-hmm.
What's the probability of both boxes has the coin that is both facing up? Both
I don't
facing.
get it, what you mean.
You know the coin?
Yes.
Yeah, facing up, facing down,
Yeah.
right? There are 2 sides.
Yeah.
So what's the probability of let's say, what's the probability of the box has a coin, it has a coin. What's the probability of a coin facing up? Half, yeah. What's the second box of the coin facing up? Half, another half. Yeah. What's the probability of 2 coins facing up?
A quarter.
A quarter. Yeah, that's what I meant. You multiply, yeah, because the first one you half, the second one half, you multiply. Okay, easy. Okay. Now, okay, so remember on the first few lessons we talked about Venn graph, right? Venn graph. Yeah, we can use the Venn graph to study the probability. Okay.
Yeah.
Look. This is the even A. Yeah, we put a big circle. And this is the even B. Probability, yeah? What's this bit? Intersection, what's this bit?
Both A and B.
Yeah, both A and B. So yeah, we can use, if it's using the Venn graph as the set, we use these, yeah? A and B. But again, we can use the probability, we use the P, right? Yeah? Yeah, can we look at this later, okay? Please. Okay, now, look, what's this bit? PA.
Yeah.
What's this bit? PB. Okay, and this is PAB, okay?
Yeah.
Okay, and now I'm going to introduce a new mathematical symbol, which is called PA vertical bar B. We call it conditional probability. So this reads as conditional probability of A given B occurs.
It's in the middle.
Look, what's this bit? Conditional of
In the middle.
probability A, yeah,
In the middle.
given B occurs. Given B occurs, where's the B occurs? This bit, yeah? Yeah? Given B occurs, probability of A, so it's this bit, yeah? In the middle, yeah? Okay? Right? Really? Probability, conditional probability of A given B occurs. Yeah? So what does it equal? Let's say, look, it's this bit, yeah? So, okay. So P A conditional probability of A given B occur equals P A and B, the middle, yeah? Remember the middle. This is the middle. This is A, this is B. This middle, yeah? This middle divided by the whole B, okay? So it's whole B. Okay? Yeah? Okay? So now look, this one, so we can rewrite this as what? P A and B equals P A conditional probability of A given B times what? Times what? We just rewrite this function times PB, right? Yeah? Okay? So what does it mean? Look, if we swap A and B, what do we have? If we swap A and B. Yeah? Because look at the A and B are two circles. They are they can interchangeable, yeah? So we can write it P B A equals P B conditional probability of B given A occurs times PA, right? Right? Yeah? So are these two equal? Are these two equal? PA and B and PB and A. Is it equal? Yeah? Is it equal, yeah? A and B and B and A is the same, yeah? It's the same. Yeah? But we are going to prove this later, okay? But now look, if we want to prove these two equal, we need to prove these two equal, right? Yeah, these two equal. So for now, we just replace this here, right? So it equals what? P conditional probability of A given B equals, I substitute this over here, okay? So it's P B conditional probability B given A times PA. Okay? So look at this. Look at this. What do we have? What do we have here?
A rectangle.
Conditional probability of A given B is equal. This is equals to conditional probability of B over given A equals times probability of A divided by probability of B. This is called naive. What's naive? Naive Bayes. Probably is the name, okay? This is called naive Bayes.
It sounds like in a different language.
Yeah, so this is the equation for this. It's just about calculating the posterior probability, yeah, based on these known factors, known probabilities. Okay. So what do we say? We want to compute these two if it's equal. Okay. Yeah. We want to compute these two to see if they're equal. If they're equal, we can substitute let PAB with PBA, right? And then we can put this, yeah? This whole thing is based on if these two are equal, right? Alright? So let's do this. Let's do it. Okay, so if we draw a table, right? Draw a table. Come on. This is the even A, and this is A dash, meaning the opposite of A. So right? Maybe the opposite, not A, okay? And this is B, not B.
I thought you write the exclamation mark thing.
Oh yeah, I'm not wearing the shirt, but yeah, it's also okay. Yeah, exclamation mark. Yeah, but this is A dash. Okay, let's say this is A, B, C, D.
A, B, C, D.
Okay, so what's the probability? What's this? P A B times what? P A B times P B, right? Yeah, we're gonna talk. What's this? P A. Given the probability of B. Given probability of B, given even B, and what's the probability of A? Given B here, yeah, what's the probability of A? It's A divided by A plus C, right? And what's the probability of B? What's the probability of B? Look, there are 4 values. What's the probability of these B?
Black.
Yeah, Eric, look at me. Come on.
Yeah.
What's the probability of B column? Given they are A plus B plus C plus D. They are a portion of A, a portion of C, right? So it's A plus C divided by A plus B plus C plus D, okay? And this cancel out, okay? So this PA, conditional probability of A given B times B is A divided by A plus B plus C plus D, okay? And what's the probability of B, conditional probability of B over A, given A occurs, times PA, okay? Let's calculate this. Look, what's the probability of A? Here, the first row, okay? And the B, so it's this bit, so it's A divided by A plus B, okay? What's the probability of A? Yeah? A plus B divided by what? All together, A plus B plus C plus D. Cancel out. So look, A divided by A plus B plus C plus D. Look, A divided by A plus B plus C. So what does it mean? Equal. What does this mean? Like these two equal. Okay, these two are equal. Okay? So what do we prove? P, A, and B equals P, B, and A. Okay? So we can substitute that formula, right? Okay? So now let's do a little exercise, okay? You know the apples, yeah? Apples sometimes they're sweet, sometimes they're not. Yeah? Apples, you like apples, yeah? Ryan likes apple, yummy, yummy. 3 apples, yummy, okay? Yeah? So I have a table, yeah? I have a table. Like color, you know, I label the colors, yeah? Like
They only can be red or like green.
yeah, but instead I use the integer to represent the color. Is that okay, yeah? Color,
Don't put a white or black one in there.
why? What kind of apples? What possibility of the colors of the apples?
Red,
Red,
green,
green,
well,
just different red, okay? You know, for the red it could be very, very red or you know.
Orange.
Okay.
orange.
Wait, and then if
yellow,
it's a sweet,
and
okay?
pinky.
If it's
Yeah,
sweet,
pinky.
pinky, okay? So let's say we have a few values, okay?
Hey, what are you looking at?
I have my note. Okay, so this is the existing. So we already know there are 5 apples, right? 2 of them are sweet, 3 of them are not sweet. Yeah. The apple with color 3 and weight 4. Weight, you know how heavy it is. So let's say 4 gram. Okay, 4 gram. The unit 4 gram is.
That's really light.
Okay, so what's the weight of this one? Kilogram is too heavy.
Too heavy. It's like a possible.
Yeah. Okay. Just represent. Okay. Okay. So we want to ask the computer to predict the color 3, weight 3. Is it sweet or not? Yes or no? Right? Remember yesterday we talked about the KNN, right? K nearest neighbors, right? Yeah. So if we plot this number, okay, let's do this with KNN first, okay? Look, let's put this here. 3, 4. If this is color, this is weight, okay? 3, 4 is here, right? 3, 4 here, yeah? It's 1. If it's 1, we use the triangle, okay? 2, 3. 2, 3 here, triangle, okay? And then 0, 3, 0, 3 is a, let's say a square, okay? 3, 2, 3, 2, square. 1, 4, 1, 4, 1, 4, square. Okay, and where's the 3, 3?
The square should be here, not there.
Okay. So where's the 3, 3? 3, 3 is maybe here and here, right?
It's there.
Okay. So that if because what's the nearest 3 neighbors? Do we have a nearest 3 neighbors?
We have.
These. Okay, so 2. Yeah, it's closest to 2 triangle, which means it's sweet. Got it?
Yeah.
Do you understand? Yeah, it's very useful. Yeah. Do you understand? Yeah.
I don't get it. Why is it
Why is what?
sweet?
Look, this point here. What's the 3 nearest neighbors with? 2 and triangle, 1 square.
Yeah.
2 triangle means the sweet. Square means not sweet. Okay.
Yeah.
So 2 triangle, 2 votes. There are 2 votes which vote for the apple to be sweet. 1 vote to be not sweet. Okay, so the probability of being sweet is higher, right? Yeah. Look, you know this is machine learning. So machine make a guess. You know what's guess? It's not 100% accurate, right? Yeah. It's a guess. You ask computer to make a guess. Yeah. Sometimes the guess is alright. Sometimes it's not alright. So it's just the best guess. So we're talking about these 3 being a sweet apple is more likely than being not a sweet apple. Okay? This is KNN. Okay? Got it? Now we want to use this probability to calculate. We want to calculate the probability of this apple being sweet or not. If okay, for example, if I calculate, let's say this apple being sweet is 50%, and being not sweet is like 20%. So do you think this apple is sweet or not sweet? Come on. If this apple I calculate somehow, you know, it's example. If this apple is probability of being sweet is 50%, and not sweet is 30%, 20%. So do you think this apple is sweet or not? We pick the sweet, yeah, because as I say, because more chance of being sweet, right? So now we just need to calculate if this apple being sweet, and if this apple being not sweet. The probability, and we compare both, then that'll be, yeah. So how do we compute the probability of apple being sweet? Okay, let's say P sweet. What's the probability of this being sweet apple? 2 out of 5. 40%, right? 0.4, right? Yeah? What's the probability of the apple being sweet and its color equals 3? Right? This is posterior probability. Look, we already know it's 3. It's 2. There are 2 apples being sweet. And what's the probability of the apple being color 3 among the 2 apples?
There's only one difference.
Look, 2 apples, one of them is 3 because we already know 50%, yeah?
Yeah.
Half. What's the probability of the sweet apple being the weight equals 3? Half is that, yeah. So P3, this is weight, okay? This is the color. Okay? So what's the probability of the apple being sweet, also color equals 3 and weight equals 3? What?
1 and 1.4.
How do you get 1.4?
Oh.
You times all this together, yeah?
Oh.
0.1, right? Remember the boxes thing, you multiply together a half times half, right? So this is 0.4 times 0.5 times 0.5, right? Because these 3 we can multiply together because they're independent, yeah? Being 3 apple, right? Color equals 3 and weight equals 3. So the probability of this apple being sweet is what? 3 sweet is 0.1, okay? Now let's calculate the other side. Alright? What's the probability of all the apples being not sweet? Come on, we already know this is 0.5, so what's the other half?
0.5.
Huh?
0.5.
5 apples, 3 apples are not sweet.
0.2. 0.3. 0.3.
3 over 5, so what's that? Yeah, 3 sweets, what's the?
60%.
Yeah, 0.6. Look, the other way is 1 minus 0.4, right? Because look, we already know the 3 apples are 40%. So not the sweet, the other, what's the next, what's the rest? It's 60%, which are not sweet, okay? And then let's say P, out of these 3, not 3 apples, and color equals 3 equals what? There are 3 apples here, not sweet. And what's the color? If it equals 3, what's the probability? There are 3. What's the probability of this? What?
3.
1 over 3, right? What's the probability of the weight equals 3 and not over not sweet? It's also 1/3, right? So you times it together. What? 0.6 times 1 over 9. So this is equals to 0.0, I don't know, 6? Okay? So it's less than 0.1. So what do you think? The apple is sweet or not?
Sweet.
Sweet, yeah? Because look, the probability is less than being not sweet, is less than being sweet, okay? So look, using this probability, you also make a guess as this apple is sweet, right? Sweet, okay? And we use the KNN also make a guess at it's being sweet, okay? So the chances are it's sweet, okay? Make sense?
Yeah.
Okay, so do you understand? Yeah?
Yeah.
Okay, so this is the probability, okay? Probability is very useful, okay? It's very, very useful. Okay, so I'm going to write this formula again, okay? Conditional probability of A given B equals conditional probability of B given A occurs, right? Times PA divided by PB. Okay, that's the formula. Let's call naive pairs. Okay? So if you know these 3 values, you can calculate this. Okay? It's very, very useful. Naive pairs probability equation. Okay, we call it that. Okay? That's it for today. Good job. Say bye-bye.
Bye.
Bye-bye. Bye-bye. Bye-bye.